Previously just a speck in comparison to giants like Mars and Jupiter, Mercury now conceals critical secrets beneath its surface. Using powerful telescopes, scientists have discovered these secrets and are observing a moving object they have never seen before. These revelations may result in crucial missions to reveal the terrifying fact that we are not alone in our universe. Let's bring to light the sinister shadow that Mercury has concealed. This tiny, swift planet completes its orbit around the Sun in just 88 Earth days, making it the fastest planet in our solar system. Mercury was not well understood historically. The planet's small size and rapid orbit made it difficult to pinpoint for early astronomers, who only had basic telescopes to study it. Scientists didn't start to get a clearer picture of Mercury until space exploration got a lot better. In the 20th century, NASA missions produced the first detailed images showing a landscape with craters. The story didn't end with these images. A flurry of academic interest was sparked by recently enhanced data from space telescopes that suggested there may be unusual features beneath Mercury's surface. The scientific community has responded with both excitement and skepticism to this interest. Based on the new information, some researchers are speculating about groundbreaking Mercury discoveries, possibly related to its geological characteristics or other aspects that were previously unknown. Projects to study Mercury further that are more ambitious have been brought up for discussion. The planet will be investigated in greater depth as part of these plans, which could lead to the discovery of new information that could alter our perception of the smallest planet in our solar system. There is excitement, but there is also a need to exercise caution due to the possibility that these plans will result in more invasive studies that could alter the natural state of the planet. It is essential to keep in mind the broader context in the midst of this renewed focus. Mercury, like all of the planets in our solar system, has its own distinct characteristics and history, which can shed light on cosmic processes like planet formation and the effects of solar proximity. Scientists must strike a balance between their enthusiasm for discovery and consideration of the research's long-term implications as they propose deeper explorations of Mercury. Although it is exciting to discover new information, it is essential to proceed in a manner that respects Mercury's environment's inherent value. It turns out that studying Mercury is a difficult endeavor, similar to attempting to take a clear picture while staring into a bright spotlight. Scientists are hampered by Mercury's close proximity to the Sun, despite years of meticulous planning and cutting-edge technology. In addition to making it difficult to see the planet, the intense heat and light of the Sun have the real potential to harm delicate instruments like telescopes. As a result, astronomers can only observe Mercury for brief periods of time to avoid damaging their instruments. Because of the risk of sun damage, even the powerful James Webb telescope can't point too close to Mercury. The obstacles extend beyond issues with visibility. It's almost like sending a kamikaze mission to Mercury with a probe. To withstand the extreme temperatures and strong gravitational pull of the Sun, any spacecraft that ventures close must be heavily armored. In comparison to other planetary explorations, which may require longer stays, this makes Mercury missions rare and brief. Mercury is the fastest planet in our solar system to orbit the Sun because it travels around it at a speed of 30 kilometers per second. Any mission that aims to land on Mercury or orbit it closely presents formidable challenges due to Mercury's incredible speed, which makes tracking and studying the planet more difficult. Only 2 brave missions have so far attempted to reach Mercury: NASA's Mariner 10, which launched in 1973, and Messenger, which arrived in 2004, about 31 years later. Our primary sources of first-hand information about the planet are these missions: 2 telescopes, spectrometers, magnetometers, plasma analyzers, and other advanced instruments made Mariner 10 essentially a mobile science lab tasked with gathering as much information as possible from its brief visits to Mercury. Using Venus's gravitational pull, the probe changed its course toward Mercury, allowing for a series of flybys that showed Earthlings the planet's surface for the first time. Mariner 10's images revealed a landscape with strange ridges and craters similar to those on Earth's moon. This challenged what scientists had previously assumed about Mercury's composition by revealing its rough and heavily cratered exterior, surprisingly strong magnetic field, and larger-than-expected core. Mariner 10 captured images of Mercury's southern polar region during its second flyby in 1974, providing new perspectives and data on this challenging planet. In March of the following year, the mission came to an end with its final flyby, which provided even more data but still left scientists wanting more complete information. This desire was made more difficult by the technical and environmental difficulties of studying Mercury. The 2,700 images and scattered instrumental readings from these missions make up the majority of what we know so far about Mercury. This is impressive given the circumstances, but it also shows how difficult space exploration can be. Each Mercury data point represents a modest victory over the vast and hostile conditions of our solar system. It demonstrates how the harsh environment of space and the limitations imposed by technology frequently impede our efforts to learn more about our planet's neighbors. As a result, examining Mercury not only quenches our thirst for knowledge, but also serves as a reminder of the inherent challenges of investigating the cosmos. Although each new discovery is a step forward, it demonstrates how slow and laborious it is to unravel the mysteries of planets like Mercury. Next, we look at what transpired following Mariner 10 and how its legacy inspired new missions to investigate the mysterious terrain. In 1975, the Mariner 10 spacecraft's mission was completed, and it remained silent in space. This marked the end of an era while also laying the groundwork for NASA's Messenger, which flew 30 years later. In contrast to Mariner 10, Messenger had a more ambitious objective: to enter Mercury's orbit. There was more to this mission than just taking pictures. It aimed to thoroughly comprehend Mercury's atmosphere, chemical composition, and physical characteristics. The mission of Messenger, which was outfitted with cutting-edge scientific instruments, was to discover Mercury's specific characteristics. The objective of NASA was clear: to collect a lot of data that would provide insights far beyond the planet's surface layers. From Mercury's magnetic field to the geological and physical structure of its core, this probe was equipped to investigate all aspects of the planet. The objective of the mission was not merely to take photographs. Rather, it was to comprehensively map and comprehend Mercury. Messenger took an impressive 200,000 photographs of Mercury during its 3 crucial orbits. These weren't just any pictures. Rather, they showed Mercury in great detail, including areas that had not been seen before on previous missions. Interesting details were revealed by the data. On Mercury's darker side, for instance, the Messenger mission's findings are significant because they provide a deeper comprehension of Mercury. This is more than just collecting data for the sake of it. This information helps scientists comprehend how planets form and function. New insights that may be applicable to other celestial bodies are provided, as well as challenges previously held beliefs. The story of Mercury's exploration is one of human curiosity and advancement in technology. The transition from Mariner 10 to Messenger demonstrates our advancements in space exploration technology and expanding comprehension of the solar system. Not only did each piece of information that Messenger sent back to Earth help us learn more about Mercury, but it also helped us see our own planet in a new way. We discover more about the universe and our place in it by studying Mercury, highlighting how interconnected and intricate the universe really is. We build on the legacy of previous missions as we continue to analyze and comprehend the information gathered by Messenger. Each new discovery contributes to the expanding body of knowledge that guides subsequent explorations. The story of Mercury and Messenger is a testament to the human spirit's persistent drive to investigate, comprehend, and constantly challenge conventional wisdom. Numerous scientists have been perplexed by a discovery made by University of California, Los Angeles researchers regarding Mercury's unusual properties. Iron typically transforms from liquid to solid at the core's innermost region on planets like Earth. However, this change occurs unexpectedly at Mercury's core's outermost boundary. This finding raises questions about how terrestrial planets were thought to behave and suggests that Mercury does things differently. It suggests that on Mercury, iron may be solidifying throughout the fluid surrounding the core, affecting the planet's magnetic field in unusual ways, as compared to a snowstorm in which snow forms at every level of the cloud, not just the top or bottom. This discovery demonstrates that the same ingredients can produce very different outcomes under various conditions, which has important implications for comprehending how magnetic fields are formed on various planets. These findings are supported by additional analysis and Messenger mission data. Despite having elements like sulfur and iron in common in their cores, it appears that Mercury and Earth behave very differently. This raises interesting concerns regarding the formation of magnetic fields on planets, implying that what we learned on Earth might not be applicable to everyone. However, the peculiar characteristics of Mercury extend beyond its core. Additionally, Mercury's surface experiences bafflingly extreme temperature variations. Temperatures can rise as high as 430 degrees Celsius during the day and plunge as low as 170 degrees Celsius at night. Mercury's almost non-existent atmosphere is the cause of these significant shifts. Mercury only has a thin exosphere made up of atoms knocked off the surface by impacts from space rocks, whereas Earth has a thick atmosphere that helps regulate temperature. The planet is not shielded from extreme temperatures or heated by this thin exosphere. It contributes to the extreme conditions that can be found on the planet's surface because it is so insignificant that it is barely visible. This aspect of Mercury challenges our presumptions about planetary atmospheres and their effects on surface conditions. It also sets Mercury apart from Earth. A clearer picture of how diverse planets can be, even within our own solar system, is provided by insights into Mercury's conditions. Depending on its particular composition and environmental conditions, each planet operates according to its own set of rules. The study of Mercury encourages us to broaden our understanding and take into account the possibility that the behavior of other planets might also differ significantly from Earth's. We are reminded of the complexity of space and its planets when we consider all of these points. Mercury's example of the unexpected teaches us that planetary science is full of surprises that defy conventional models. We are likely to encounter additional examples that challenge our existing knowledge and push the boundaries of what we know about the universe as we continue to investigate additional celestial bodies. We are compelled to keep asking questions and looking into the vast unknowns of space with each new discovery because it deepens our understanding. Now that Messenger's journey has concluded, we move on to Mercury's extreme conditions and unexpected events. Mercury, which is a year shorter than a day, primarily draws scientists due to its extreme heat. Gases are likely to evaporate into space before they can accumulate because of this intense heat, which prevents the formation of any stable atmosphere. Because Mercury lacks an atmospheric layer to protect it, one side experiences extreme heat from direct sunlight while the other side remains cold and dark. Mercury's peculiar day and year lengths make it stand out. It takes 176 Earth days for Mercury to complete one full rotation on its axis, which is considered a day. In contrast, Mercurius' orbit around the Sun takes only 88 Earth days to complete in a Mercurian year. This anomaly causes one side of the planet to be scorched by the Sun for long periods of time while the other side has a long night. It seems far-fetched that any kind of life that is similar to life on Earth could survive in such circumstances. The harsh environment of Mercury, on the other hand, has sparked a lot of discussion and speculation among scientists. Mercury is similar to Earth in some ways, such as having a magnetic field and rocky terrain in its composition. However, these similarities largely end there. Given Mercury's harsh climate, the idea that it could be a home for life challenges our biology knowledge. Interestingly, like our Moon, Mercury's surface is littered with numerous impact craters. Since each new discovery on the surface of the planet leads to more hypotheses about what might be possible there, these craters are frequently the subject of speculation. Because of this, some people have started to speculate about the existence of potential life forms that might be able to survive in the harsh environments of the cooler, shadowed craters, or make use of the minerals in the rocky soil. These life forms might be particularly well-suited to the extremes. Considering life forms that are vastly distinct from those found on Earth is often required when developing theories about life on Mercury. Could radiation-dependent organisms exist, or could life exist without water? Such inquiries venture into more speculative biology and test the limits of current scientific thinking. In addition to the search for life, this ongoing interest in Mercury aims to comprehend the limits of planetary environments where life might exist. Scientists use every theory, no matter how imaginative, to consider the possibility of life's resilience and adaptability in conditions unlike any we've ever seen. In addition, Mercury's harsh conditions serve as a reminder of the diverse and extreme environments found on planets. Even though it's tempting to imagine other planets as places where undiscovered forms of life might be found, the reality frequently emphasizes Earth's biosphere's singularity and fragility. As a result, Mercury is more of a topic for theoretical research than a serious contender for colonization or life support.